In this video, we're going to talk about independence and how it relates to probability. If we talk about an English meaning of independence, you're probably thinking like freedom or ability to do whatever you like, maybe even the holiday. But that's quite different than what we mean in math, even though there are some overlaps. For math, in kind of non-technical language, it means that any other event won't change the probability of the event in question from happening. So whatever happened in the past is not going to happen in the future. They have no relationship on each other's probabilities. There's a formal way to determine this with a probability rule, but in general, as you get started on problems that deal with independence, just have an idea of something is not going to affect another thing. The probabilities won't change. So here's an example from sampling. If you're randomly selecting individuals, then we get to assume that they are independent of one another. That's kind of the idea of being random, that one outcome is going to be totally independent of the other outcome. So if you're picking people or selecting houses from a county map or something, they're not going to be dependent on each other. Another way to look at this is that some textbooks say that if your sample size is less than 5% of your population size, then generally it's okay to treat those sampled as independent from one another, even if they really are dependent. The idea is that if your population is really large and you're selecting people from that population, the population is just so large that it's like there's so many options in the population, they're not going to affect each little outcome as you select them, as you sample them. Some classic examples of independence from probability are coins and dice and cards. It's not quite as popular anymore to use those examples, but you might come across them. If you roll a die, one side is not going to affect the ability to get another side. So from roll to roll, it's like starting fresh. Whatever happened in the past is not going to affect the future. Same thing with flipping a coin or drawing a card from a deck of cards, but you have to specify that you are replacing the card. If you leave the card out, you have a different deck of cards. It has like 51 cards instead of 52. Babies, another example where the first kid is not going to have any bearing on the gender of that second kid. So if you had a girl first, when you go to have the second kid, it's still a 50-50 chance, boy or girl. I won't get into like semantics of, the exact probability of boy or girl, but just go with roughly 50-50 here. Now, don't confuse this and try to think too much more and say, well, if you have 3 kids, then the chances of having a girl, all girls, is really different. That's a whole different question. That's looking at the whole sequence of 3 in a row kids, not first kid, what are the chances of the boy or girl, and the second kid. Those are 2 different questions. If you do something in sequence, like a coin, flip a coin, and then look at the sides of a die that you roll. Whatever you get on the coin isn't going to have a bearing on what happens on the dice. Some real-life examples of independent outcomes. If you randomly select a Florida man and an Oregon woman and ask their opinion on gun control, they'll probably give you completely unrelated responses. Even if you happened, well, I shouldn't say unrelated responses, but they're not going to be affecting each other. Maybe if you happen to totally randomly select these people happen to be brother and sister, let's say, it was still done randomly. So even if the 2 people are related to one another, the intention was that you went out there and independently selected, and that's okay. That's all that matters. If you get a speeding ticket in Oregon, it won't affect the chances of you getting a speeding ticket in Vancouver, assuming you're not speeding in either places. 2 different regions, different police departments, so you won't be getting there won't be a higher chance of getting a speeding ticket in Vancouver than if you're still not speeding in Oregon. If it rains today, it won't affect whether it rains a month from today. So it's far enough time away that today's weather is not going to affect what happens in a month. Now, today's weather might have an influence on tomorrow's weather. Let's say the clouds stick around or the sun sticks around. But that far out, it's more or less independent. So some dependent outcomes. We kind of know what it means to be independent, so let's contrast that with dependent outcomes. If you draw a card from a deck and leave it out, it will change the probability of what you can draw next because you have a smaller pool of cards. Same thing with the classic example of drawing a ball from an urn, which is just like a jar. You have different colored marbles in an urn. If you leave out one of the colors of marbles, it will affect what you can get next time. Some real life examples of dependent outcomes would be asking related people their opinions, the chances of them saying yes on a particular issue. If they're married, they probably have similar values, so they might give similar responses. If you study harder for your psychology test, that prevents you from having as much time to study for statistics. So the effort that you put into psychology could affect your ability to get an A in statistics. If two cars are driving down the highway, the car in front of you slows down, then it forces you to slow down. So the chances of that first car slowing down, it's going to affect whether you slow down or not, unless you want to crash, and I don't think that's the case. More dependent outcomes, twins. If you choose twins or triplets or anything higher, they share DNA. There's some sort of relationship between them, so their responses would probably be similar to one another. They would not be independent from one another. So all these examples are just kind of ideas of independence and dependence. Nothing has been formally proven, although it is possible. Those would be saved for a later video. When you're working on probability problems, don't assume independence. It's super easy to do that, but most of the time the goal is to figure out if outcomes are independent. So you can't start by assuming that they're independent to begin with if the goal is to show independence or not.